Hi everyone, welcome back. So in this video, I'm going to talk about the method of separation of variables for first order differential equations. So let me give you a brief intro of what is this method and then how do we use it. We'll do one example. So the idea with this method is to be able to separate the two variables. So for instance, we want to be able to do, say, f of x. So you have a function of x. You want to be able to separate that with dx. And then you have g of y. So another function of y with dy equals to anything. Let's just say 0 for now, or a constant. Let's just call it a constant. So I'm able to separate the x variable and y variable. That's what we call a separation of variables. And then from there, we just do simple integration that you remember from calculus and proceed. So let's take a look at our first example. So here I have a differential equation. It's first order. You can see it's dy dx. And we want to find the general solution to this. So we're going to use the method of separation of variables. And it looks like we can do it by simple manipulations. So if I just observe the equation and say, okay, I want to tag in dx with the function of x and dy with the function of y. So we can go ahead and move this piece and then move this piece away from dx. So then we should have the separation of variables. So I'm going to go ahead and divide both sides by sine of y. So we have cosine y over sine y dy. And then I'm going to divide both sides by x minus 1. So on the right side, I have 2x over x minus 1 dx. So here I have a function of y, and here I have a function of x, just any function. Well, now that we have successfully separated the variables, now we can go ahead and integrate both sides because we're looking for the solution. So you want to find y as a function of x equals to something. So let's go ahead and bring in the integration symbol on both sides. So we integrate the left side and we integrate the right side with its respective variables. Now, cosine over sine, well, here you can do a u substitution and then proceed from there. So let's see. Cos, I can pick a u to be the denominator, which is sine of y. Then the derivative of u is going to be cosine of y dy, which I have in the integration. So that means now my integration translate everything in terms of u and du. So you have the integral of 1 over u times u prime, or I can just simply write du, the derivative of u, is equal to, now what about on the right side? We're integrating 2x over x minus 1. So for the right side, we can also do another substitution. Well, so let's see, we're not going to pick u for the right side, we're going to pick w. So let's pick w to be x minus 1, and then w prime, or dw, it's going to be dx, just 1. So what I can do from here, I can solve for x. So this means that x is equal to w plus 1. Okay, so these are the substitution I'm going to make for the right side. Okay, so I have 1 over u du on the left side. On the right side, I have the integral of 2 times x. Well, this is going to be 2 times w plus 1, because that's what x is. And then dx is going to be just dw. So pretty cool, nice and neat. Well, now we can proceed to integration. So on the left side, we have 1 over u du. Well, that is simply just ln of u. Now we're going to hold on to the integration constant because we're going to tag that in at the end. Is equal to, now on the right side I can take out the 2 and then integrate w respect to dw. That would be w squared over 2 plus the integral of 1 will just be w. Now we can put in the plus c. So we're now done. Now we just need to substitute in what is u representing and what is w representing. So let's substitute what u is. U is sine of y. So we have ln of sine of y is equal to, now on the right side we're going to distribute the 2 and then substitute what w was. W happens to be x minus 1. So we have x minus 1 square plus 2 times x minus 1 plus c. Now here you're pretty much done, but the rest is simplifying the answers. So I'm going to go ahead and distribute the 2 a little bit more and then combine that constant with the plus c, since if you have more than one constant flowing around, you want to combine it into just a single constant. So finally we have ln of sine of y is equal to x minus 1 square, then plus 2x, and then here it's going to come out as a 2, negative 2, and then we have a plus c. But both of these together, I just call it 1 plus c. So just a single plus c. And that will be our final answer in implicit form. If you want to go ahead and find the explicit form, meaning solve for y, you can go ahead and do that, but pretty much the idea of separation of variable is explained. All right, so I hope this makes sense. See you next time.